It's truly remarkable how detecting stars that are extremely distant or closest in time to the Big Bang can provide us with insights into the earliest chapters of our universe's history. The Hubble Space Telescope broke its record in 2022, spotting the most distant star, which has been fondly named Earendel. The fact that this star emitted its light within the first billion years of the universe is simply awe-inspiring. But that's not all. NASA's James Webb Space Telescope has also recently played a crucial role in confirming the star's distance. It has provided us with invaluable insight into its star type and surrounding galaxy. With future analysis of Webb spectroscopic observations, we may learn more about Earendel's brightness, temperature, and composition, offering us an even deeper understanding of the universe's earliest days. Indeed, advancements being made in space exploration are nothing short of amazing. When was Earendel first discovered? In 2022, a groundbreaking discovery was made by the Hubble Space Telescope. It captured the most distant star ever observed, Earendel. This star is at least 50 times bigger than our Sun and has an astonishing temperature of 20,000 degrees Celsius. But hold on, it's not just far away, but is also ancient. Earendel is located 12.9 billion light-years away from us, meaning that to reach it, we would need to travel at the speed of light for an incredible 12.9 billion years. And even if we could get there, we would discover the star already dead, as its light was emitted 12.9 billion years ago, 900 million years after the Big Bang created the universe. Scientists believe that Earendel exploded millions of years ago, but Hubble was able to detect it thanks to an extraordinary coincidence. As we know from a theory of general relativity, the gravitational force of massive objects, such as a cluster of closer galaxies, can act as a lens to magnify the light of objects much further away. And that's precisely what happened with Earendel. The light was magnified by a cluster of galaxies, allowing us to observe it from such an incredible distance. Earendel is situated in a galaxy that goes by the name of Sunrise Arc. This particular galaxy's light has been magnified and distorted by gravitational lenses, a phenomenon that can be likened to a curved piece of glass that alters the image it reflects. A gravitational lens enhances the light of faraway objects that happen to be in alignment with a cluster of galaxies. This occurs because the galaxy's significant mass distorts space-time around them, causing the light of distant stars to be redirected. As detailed in a study published in Nature, the new star's moniker is derived from Old English and translates to morning star or rising light. Furthermore, the discoverers of Earendel also pay homage to John R.R. Tolkien, the author of The Lord of the Rings, by referencing his 1914 poem, The Voyage of Earendel, the Evening Star. If the validity of the Big Bang theory holds true, it means that we are currently observing a celestial body that came into existence during the initial billion years of the cosmos, and therefore may be a part of the first generation of stars that astronomers have been in search of for decades. Due to its limits, the Hubble telescope couldn't tell us everything about this faraway star, so scientists used the James Webb Space Telescope to further study Earendel. By combining the observations from both telescopes, scientists could better understand microlenses and galaxy clusters, including the existence of exotic objects such as primordial black holes. As it turned out, the James Webb Telescope proved to be quite the star player for astrophysicists. It provided a more precise picture regarding the composition of the primitive star, which was believed only to contain the lightest elements. This was because metals and other heavy compounds hadn't yet formed after the explosions of dead stars. The team was thrilled with the new insights and couldn't wait to see what other discoveries they could make using this powerful tool. James Webb has captured the best image yet of the most distant star in the universe. In the observations made by the James Webb Space Telescope, 3 noteworthy points emerge. Firstly, there's the observation of the star's redshift, a crucial metric for gauging the distance of celestial objects in the vast expanse of space. The latest Webb observations reveal that Earendel possesses a redshift of 6.2, which matches the findings of the Hubble Space Telescope from early 2022. This achievement elevates Earendel, making it the star with the highest ever recorded redshift. The previous record holder, detected by Hubble, was observed approximately 4 billion years after the occurrence of the Big Bang. Another crucial insight provided by the Webb telescope concerns Earendel's bolometric magnitude, which quantifies the total energy it emits across the entire spectrum of light. The Webb data eliminates the possibility of Earendel being a low-mass star, a brown dwarf, or a free-floating exoplanet that was gravitationally lensed. Instead, the information indicates that Earendel belongs to the B-type star category with a surface temperature ranging from 13,000 to 16,000 Kelvin. Stars in the universe are categorized into 7 primary groups based on their temperature: O, B, A, F, G, K, and M. However, a challenge arises when calculating Earendel's overall luminosity, which falls within the range of 600,000 to 1 million times greater than that of our Sun. This implies that if Earendel is a solitary star that has evolved, it must be approximately 40 times more massive than the Sun. Alternatively, there's another feasible scenario for generating such immense brightness. It could come from 2 stars, each around 30 times heavier than the Sun, or a 5-star system with each star weighing approximately 20 times more, assuming they have a surface temperature of roughly 15,000 Kelvin. It's not uncommon for stars as massive as Earendel to have companions. Despite this, astronomers did not anticipate that any companions of Earendel would be discovered through Webb. This is because they would be situated so close together that they would appear indistinguishable in the sky. However, by evaluating Earendel's colors alone, astronomers believe they have identified subtle indications of a cooler, redder companion star. The light associated with this companion has been stretched by the universe's expansion to wavelengths longer than those detectable by Hubble's instruments, meaning it was only possible to identify this companion star using Webb. The existence of this companion resolves another scientific puzzle and underscores the accuracy of our comprehension of stellar astrophysics. This is because if Earendel possessed a brightness equivalent to 1 million times that of the Sun, it would have surpassed the Humphreys-Davidson or HD limit. The HD limit represents an empirical luminosity threshold, beyond which no stars have been observed, at least within the local universe. Thanks to Webb's NIRCam, we can see so much more than what we previously thought possible, including discoveries within the Sunrise Arc, the most highly magnified galaxy yet detected in the first billion years of the universe. This galaxy boasts features including young star-forming regions and older established star clusters that are incredibly small, some being just 10 light-years across. What's even more impressive is that on either side of the wrinkle of maximum magnification, which runs right through Earendel, these features are mirrored by the distortion of the gravitational lens. The area where stars are formed appears elongated and is estimated to be just under 5 million years old. Furthermore, we can see smaller dots on either side of Earendel, 2 images of one older, more established star cluster, estimated to be at least 10 million years old. Astronomers have determined that this star cluster is gravitationally bound and likely to persist until the present day. This shows us how the globular clusters in our Milky Way might have looked when they formed 13 billion years ago. Astronomers are thoroughly examining the information gathered from the Near-Infrared Spectrograph or NIRSPEC instrument and the observations surrounding the Sunrise Arc galaxy in Earendel. This analysis aims to obtain a precise understanding of the composition and distance measurements of the galaxy. This process is expected to yield valuable insights into the nature and behavior of the galaxy, which would be of immense significance to astronomy. The discoveries made by the Hubble telescope have been groundbreaking in stellar physics, including the discovery of Earendel. Since then, the Webb telescope has also successfully detected other faraway stars, although none have been as far as Earendel. These discoveries have opened up a whole new realm of the universe for scientists to study the early universe. Previously, galaxies were the most miniature detectable cosmic objects, but now, with the detection of distant stars, scientists have a new subject matter to explore. The research team is optimistic that this could be a step towards detecting one of the first-generation stars. These stars were composed only of the raw ingredients of the universe created during the Big Bang, hydrogen and helium. This exciting prospect could provide valuable insights into the birth of our universe and the formation of stars and galaxies we see today. As we continue to explore the mysteries of our universe and our place in it, the work of Webb and other space exploration projects becomes increasingly important. With the ability to look beyond our solar system and probe the universe's origins, our discoveries can fundamentally shift our understanding of the world around us. Who knows what secrets lie waiting to be uncovered? With Webb leading the way, we are progressing towards answering some of the biggest questions in science today. We hope that you found this video entertaining. Please join us next time for more captivating updates from the realm of space exploration.